Welcome everyone. So in this video, I'm going to focus on the square of the correlation coefficients. It is called the coefficient of determination, or R squared. Now algebraically, R squared is just the square of R. You know what R stands for? It measures the strength of the relationship between your two quantitative variables, and it's always between -1 and 1. If you square that number, you will get R squared, algebraically speaking. So if R is, let's say, this number, then R squared is just square this number, and you will get exactly 0.75. Now, so I just picked pairs of points, one representing the independence variable, and one represents the dependence variable. I cooked them up in such a way that my averages or my means are integers. It just makes the calculation a little easy. So clearly the mean of x is 4 and the mean of y is 9 divided by 3, which is 3. Okay. Now, if you were to do a scatter plot of this, you could do stat calc number 8, and you will get the y-intercept to be -3. I hope you could do it by yourself. You're going to get the y in the slope to be 3/2 or 1.5, and then you will get r and r squared for free. You'll get this, all of this for free. Now, as I mentioned, r squared is just the square of r. Now, the scatter plot should look, don't let this picture throw you off, okay? So I want you to focus on anything that is black. So I plot the point 3,1. So here it is. That's the first point. The point 4,4 is here. And the point 5,4 is here. So I have 3 points only because I don't want to spend too much time doing calculations. And I'm going to draw my least square regression line. We know A is -3, and we know B is 3/2 or 1.5. Now, the way you draw it, you just think of a basic course in Algebra 1. I would suggest you do the following. Obviously, you have the right to pick any x and get the y value, right? You could say when x is 0, y is -3. So that's this point. You could say when x is 1, y is -3 plus 3/2, which is -3/2, right? But I would suggest you could pick any x you want and get the y value. You obviously need 2 points, okay? You need 2 points to draw the line. I would suggest the following. Always pick the y-intercept. Why? Because it's there, right? It's there for you. And I hope you guess it. Pick x bar, y bar. Why? Because x bar, y bar is always on the least square regression line. It is in blue right there. So if I pick 4, 3 and 0, -3, I have my 2 points, and now I can superimpose the least regression line on my scatter plots made of 3 points only, right? So I hope you'll be able to put this point here, put this point in blue here. I'll put this one in blue as well to remind you that these blue points have nothing to do with the scatter plots. These are not invented, but these are the 2 points we picked to draw the line, okay? If you choose to pick a point, let's say 10, that's fine. You have the right to. It's silly, but you have the right to, okay? You can pick whatever x you want and get the y value based on my equation. Okay, that's just Algebra 1. Okay, so now you draw the line. So we did. Here is the line. I gave it its name. And now what I'm going to do is I'm going to focus on how we initially, the mathematicians came up with this line. And we said what we want to do is minimize the total number of squares, minimize those rectangles. And I'm doing them in green. So if you look at this point, for instance, you draw this point, you draw line segments from this point to the line. So that's definitely a residual or an error. and it is negative because it's below the line. And out of this length, you create a little square. Now that residual happens to be, I actually did it for you here. So let's focus on this point, for instance. To find the residual of this point, how far is this point away from the least square regression line? As you know, it's just y minus y hat. Y is just 1. That's obvious. Minus y hat. Y hat, that means you, when x is 3, right? When x is 3, what is the y hat? So it's negative 3 plus 3 halves times 3, right? So that gave me 3 halves. So 1 minus 3 halves is negative 1 half. In other words, this error here is negative 1 half. Notice it is below the line, so it has to be negative. That negative half, that distance is a half. You create a half by half square, and you get, I made a mistake here. I should say 1/4, right? I should say 1/4 because the area of the square is 1/4. Okay, so let's look at the other one. The second point is here. It's 4 comma 4, this one. And if you plug that in, I get 1. I got 1. The error is 1. So 1 by 1, so that is an area of 1. Okay, look at the green, don't look at the red, okay? Then the third point, which happens to be here, I hope you realize the error or the residual is negative. I found that it is also negative 1 half. So if you multiply this half by this half, you get an area of 1/4. So my areas are 1/4 and 1 and 1/4. Here they are. So it's negative 1 half, which I just did here, square, plus 1, look at the green, square, plus half, I should say negative half, right? I should say negative half because we know the point is below the line. Negative 1 half squared. So that total, the sum of the residual squared, these green areas together, gives you 3 halves. And I am making a claim that nobody can come up with a line that tries to capture these 3 points as best as possible and get a sum more, I should say less, or even equal to 3 halves. This is the best you can have. It's called the sum of the residual squared. Okay? So this is the stuff you know. This is the stuff we've done in the past. Now, in order to calculate r squared, in addition to the fact that you could just square the little r, there is a difference method. It's not a better method because the quickest method is just to square this number to get that number. But this approach I'm taking right now will help you understand what r squared stands for. That's the whole point, okay? So here's what we're going to do. We're going to go to the x bar, y bar, which is always on the line, okay? We're going to draw a horizontal line through that point. So clearly that line is called y equals 3. And I'm going to repeat the process with these 3 points. But I'm not going to draw line segments from the points to the line. I'm not looking for the residual anymore. I'm going to draw line segments from these 3 points that are given to you to the horizontal line. And that's why you see the green. So for example, if you look at this point, to draw a line to here, that's y value is 1. So that's 1. You go all the way to 4, right? I made a mistake. Maybe I didn't. Oh, no, I didn't. So this is 1. You draw the line to 3, not to 4. That's why. So this is 2. And therefore, this area is 4. So that's where this number comes from. I'll explain this later, okay? Then you draw the distance, the line segments from this point to the horizontal line. Now the y value here, so the right ones are much easier. You just look at the y value, 4, and you go down to 3. So that's 1. 1 by 1 is 1. Okay? Same thing here. This point here, the y value is 4 as well. 4 to 1 gives me 1. Not that one, okay? 4 to 3 is 1, and you square 1, you get 1. Okay? So what these red are, these areas. What these greens are, these green terms are being squared already, like a fourth plus a 1 plus a fourth, are the green areas. Okay? Now I claim that by drawing this horizontal line, this squares, the area of this squares will always get, it's like the worst case scenario. This is the biggest possible sum of squares you could have. It has a name called the total sum of the squares. I know we don't write TSS, we write SST. Total sum of the squares. That is basically you take your y1 minus y bar squared plus y2 minus y bar squared plus y3 minus y bar squared. That's all I did here, right? I took y1 minus this one squared, you got 4. Take y2 minus y bar is 3, okay? Squared, you get 1 squared, and then you take y3 minus y bar, which is 1, squared, you get 1. That's all that this means, and that's all this means, okay? So, in sum, to summarize, if you add the areas in red, you get 6. If you add the areas in green, you get 3/2. And r squared happens to be this total, this big giant sum of squares, it's called total sum of squares, minus this sum divided by the total. Notice that this is a fraction. Small minus large minus small divided by the total. So that's going to give you a fraction less or equal to 1, which makes sense. In fact, if you square little r, I'll write it here for you. I'll do it here. Here is r, which happens to be between -1 and 1. When you square it, you gotta get a number between 0 and 1, right? So anything you square here is gonna land here. Anything that you square from here, it's gonna also land here. Notice also that r squared is always less or equal to r. So for example, if r is a half, r squared is a fourth. And 1/4 is less than 1/2, right? Makes sense. Think of y equals x, and think of y equals x squared. This is 1. Any number between 0 and 1, when you square it, it's smaller than the original number. If you square a third, you'll get a 9th, which happens to be also less than a third. And of course, it's no surprise, it's not surprising that r is bigger than r squared. Makes sense? All right. So when I do 6 minus 3/2 divided by 6, I got exactly 0.75, which is the square of this little r. Now, why did I care to show you this? It is, for one, it is to show you where the definition comes from. So what does r squared stand for? We know what r stands for. It measures the strength of the relationship between my independence and my dependence variable. So what is r squared? R squared is the fraction of the variation in the values of y. It's the fraction of the variation in the values of y. Of course, that is accounted by the line of y on x. It has to be accounted by the line of y on x, but it is the fraction of the variation in the values of y. Okay, let me point out something else. This is like algebra 1. So if I have, let's say, a big number minus small number divided by the same big number. So let's say 10 minus 3 over 10, okay? Now, you know it can be written like this, right? And therefore, it is 1 minus s over b. In other words, this r squared can be written as 1 minus the sum of the residuals squared, which are the green squares, the total sum of the green squares, divided by the total sum of the squares, which is the sum of the red squares. Notice that this is always smaller than that. In fact, this is the smallest you can have. Can't beat this number. And this is the biggest, so this fraction is less than 1. And if you subtract a number less than 1 from 1, you're going to get a number between 0 and 1, right? Now, of course, if the points are all on the line, notice what happens. First of all, there is no residual. All residuals are 0, right? And therefore, the sum of the residuals squared is also 0. Which means this is 0. And 0 over a number called red is 0. And 1 minus 0 is 1. Makes sense. In other words, if you have a scatter plot and a line directly on it, we know for a fact that r is going to be 1. And therefore, r squared has to be 1, which is confirmed by this formula as well. Okay, so what is r squared? R squared is the fraction of the variation in the values of y. That is accounted by the least square regression line of y on x. I know it's a mouthful, but you've got to know this, okay? The last thing I want to say before I stop this video, we always express r squared as a percentage. So I don't want to see r squared equals 0.75. Your calculator will give you 0.75. If we ask you to interpret r squared, you say r squared equals 75%. And then you say, which is the fraction of the variation in the values of y that is accounted by the least square regression line of y on x. Okay? We always express it as a percentage. Always. Another way to think of r squared, by the way, which I think you will appreciate, think about it this way. See these 3 points? That's your scatter plot, right? And this is the line. If I were to ask you, how many points were captured by the line? Well, visually, you're going to say 0. None of them is on the line. This r squared gives you the percentage of points on the line on average. You might say, well, that's a contradiction. You just told me none of them is on the line, so 0%. And now you're telling me 75%? The reason it is 75%, not 0%, because I only had 3 points. If I had like 100, I can guarantee you, give or take, about 75% of them will be captured by the line. Does it mean that if I have 100 points, 75 of them will be on the line? No. That's on average. That's on average. Because, for instance, let's say I have 100 points. It doesn't mean that 75 are on the line, 75 of them, and 25 are not. That's not what it means. That's just because this point here, for instance, it's not on the line, but it is so close that sometimes a couple of points that are so close would account for one of them on the line, so to speak. In other words, a point here is not on the line, and a point here is not on the line, but this point is much better than this one. Accounts for like 10 of these. If I have, look, if I have 9 points here, so close, they will literally account for 1 point that is so far out. So that what this means is, on average, 75% of the points will be captured by the line. It does not mean that 75 will be on the line and 25 will not be on the line. Make sense? But I would suggest you stick with the definition of r squared, which is the fraction of variation. And its name is called the coefficient of determination. And it is always between 0 and 1. Just like an old friend called rho. You remember rho? Yeah. So it resembles r squared, it resembles rho in a sense that both of them are between 0 and 1. That's the only thing in common they have, all right? So I am going to end this video, and I will see you next time.